A marker M out at sea has a bearing northeast and is 10 root 2 kilometers from a port O. Find its coordinates. So its bearing is northeast. Now that means that we look east and we veer 45 degrees north. So this angle is 45 degrees. Now we want the coordinates of this point, so we have this right angle triangle here. The side adjacent to 45 degrees is the x coordinate of point M. The side opposite 45 degrees is the y coordinate of point M. The cos of 45 degrees is adjacent, which in this case is x, over the hypotenuse, which is 10 root 2. So x equals cos 45 times 10 root 2. Now in surd form, cos 45 is 1 over root 2. So we have 10 over root 2 multiplied by 1 over root 2. That just gives us 10. The sine of 45 is opposite over hypotenuse. The side opposite 45 degrees is the y coordinates of M. Is the y coordinate of it, so it's y over 10 root 2. Now the sine of 45 is also 1 over root 2, so y is 10 root 2 times 1 over root 2, that's 10. So the coordinates of M are 10, 10. Two ships A and B leave port O at the same time and travel along paths OA and OB respectively. There's OA, there's OB. So that the closest approach each is from the marker is 2 kilometers. Find the bearing of each path to 2 decimal places. So both ships are travelling in straight lines, and M is a point that's equidistant from the 2 straight lines. The distance of M to each line is 2 kilometers. Let's look at this right angle triangle here. We have 2 sides of it. The hypotenuse of it is 10 root 2. One of the short sides is 2 kilometers. So now we can get the distance of O to A when A is 2 kilometers from M. So we can just use Pythagoras on this right angle triangle. So 10 root 2 squared equals 2 squared plus OA squared. So if you solve this equation, get 10 root 2 squared, subtract 2 squared and get the square root, you'll get 14. So the distance of O to A is 14. Now, what we're after, of course, is the bearing of ship A. To get the bearing of ship A, we need this angle. So it's going to be east so many degrees north. To find this angle here, we'll have to get this angle in here. Now this is an angle in this right angle triangle, and we can use basic trigonometry to find this angle. Actually, we don't need the distance of O to A, at least not in this part of the question. We might need it in another part, so it's useful to have it anyway. Let's look at this angle here. I'll call this angle A. To find angle A, we could use the sine rule. We could say 2 over sine A equals 10 root 2 over sine 90 degrees. Or we could use one of the ratios of sides of a right angle triangle. We could say that the tan of A is 2 over 14, or the sine of A equals 2 over 10 root 2. So there's a number of ways we can do this. I'll use the tan of A. It's opposite over adjacent. That's 2 divided by the adjacent, which is 14. Here is 2 over 14. We want the inverse tan. It's 8.13 degrees. 2 decimal places is probably good enough. Actually, I'll write it down to more than 2 because we want the final answer to 2 decimal places, so maybe I'll write it down to 3 places. Well, to 3 places it's also 8.13, so that's good enough. So that's A. So how do we find this angle in here? That's the bearing of A. Well, we know that this angle is 45 degrees because we were given that M is northeast of point O. So all we do is we have 45 and take 8.13 from it. To 2 decimal places, this is 36.87. So we could write our bearing like this. We would write east 36.87 degrees north. So we look east and we veer 36.87 degrees north. Now, how do we find a bearing of ship B? Well, we're interested in this angle here. But well, you can see from the diagram that there's a certain amount of symmetry. this angle A is equal to this angle here. These two angles are the same. The reason for that is because if we have a point that's equidistant from two arms of an angle, so this line and this line are the arms of angle theta, then the point is on the bisector of the angle theta. So that's the converse of a theorem that we looked at earlier. We looked at points on the bisector of an angle. We saw that they're equidistant from the arms of the angle. Conversely, if a point is equidistant from the arms of the angle, then the point must be on the bisector of the angle. So this line here bisects angle theta, so if this is angle A, then the angle next to it is also A. So it's just a matter of adding on if we want to get this angle here. So we have to take this angle here, which we already have. We know that this is 36.87, and add A onto it twice. Add this value onto it twice. So for ship B, the bearing is east 53.13 degrees north. A travels at 40 kilometers per hour and B at 30 kilometers per hour. Find how far each has travelled after 2 hours. So A is travelling at 40 kilometers per hour. So presumably that's a constant speed of 40 kilometers per hour. That means in 1 hour A will cover 40 kilometers. In 2 hours it'll cover 40 times 2 or 80 kilometers. B covers 30 kilometers in 1 hour. Again, I'm assuming that B is travelling at a constant speed of 30 kilometers per hour. So each hour it covers 30 kilometers. So in 2 hours it'll cover 2 times 30, which is 60 kilometers. Find tan theta, where theta is the angles between lines OA and OB. Well, that's straightforward now, because we got this angle A. Theta is just 2 times angle A, and A is 8.13 degrees. How far apart are the two ships after 2 hours? So the two ships left Port O at the same time, and in 1 hour ship A will have gone 80 kilometers. In 2 hours ship B will have travelled 60 kilometers. So here's the picture. We have the angle between the paths of both ships. It's 2 times 8.13, 16.26. And we want to see how far apart the ships are after 2 hours. So here are the distances of the two ships from Port O after 2 hours. So we want this distance here. So in this triangle, I will call it side we're looking for small a. And if this is small a, then this angle is capital A. So this is just a well-known application of the cosine rule. We don't have enough information to use the sine rule. We have to use the cosine rule. We have two sides, an angle in between, and we want to find the third side. So we call the other two sides B and C. I'll call this one B and I'll call this one C. And here's the cosine rule. So we just plug everything into this and we can find the distance between the two ships. So here we have it. We have 80 squared plus 60 squared minus 2 times 80 times 60 times the cos of 16.26. So this will give us a squared. And we want a, so we have to get the square root of this number. So if you put this number to the power of a half, you'll get the square root. So you can see that the ships are very nearly 28 kilometers apart. I'll write down 28.